Hello, welcome to session number 13 in the series Digital Circuit Design using VHDL. My name is Anurag Nigam, and we were discussing some of the concepts which are more useful towards testing rather than in synthesis. Earlier we were covering synthesis using Vivado and targeting Xilinx FPGA. Now we are looking at some of the constructs which are sequential. We have seen a process, and we have seen how the process is activated using sensitivity list. It has got signals. If there is an event on the signals in the sensitivity list, the process block is executed, and all the statements inside the process block are sequential. Only simple assignments are allowed in the process block. Now we are going to see some more things like package and package body, right? So first of all, I'm going to create a new file in my project and call this as CKTS. So my package is called CKTS, and I open it. It is a blank file, right? So what I'm going to do here is I'm going to write a package, and we have seen how to write a package earlier, but we haven't seen what is a package body. So that's what we are going to see. So use IEEE dot std underscore logic underscore 1164 dot all. So these are the usual lines. Then you can start a package, and then you can say package CKTS is, and then you can say end CKTS. So this is how a package is written. Now this is an empty package, and then if I write a package body, it will be written this way: package, just a keyword body is added, the name remains same, and then you say and CKTS. So this is how a package body is written. Now a package, okay, so package is a primary entity in VHDL, as I have earlier covered, while package body is a secondary entity. That means that a primary entity has to exist, right, for the secondary entity to be defined like this. This is not possible that you have a secondary body which is independent. Secondary body is dependent on the primary body. So package body has to have a package declaration, right? So let's see if this works. So if we compile, so it says successful, means that there is no syntax error here. So now I'm going to first talk about constants. So when I say constant, so this is a keyword, and then I can say pi, for example, is a constant which I'm trying to define, and it is of type real because it has a decimal point. Now as soon as I do this, I am forced to give it a value, because a constant is supposed to have a value and it is not supposed to change, right? So this is how you can define a constant. So as soon as you define the type, you give it a value, right? So if I was to save this and compile it to see if the syntax is correct, right, so I can say compile selected, and it's successful, means that the syntax is correct. Now if I don't provide it a value, this is going to complain, because this is an incomplete definition of a constant. So if I was to save this and if I was to compile this, it says failed, and if I double click this, it says pi at line 6 has no corresponding full declaration. So what it means is that it's incompletely defined. Okay, so this is known as a deferred constant. So deferred constant can be there in a package, but it has to follow up with its complete definition in a package body. So I can say constant pi, and I can say here it is a real, that's half the definition, and now this is the full definition, 3414, right? Now somebody might say that what is the point in doing this? Okay, sometimes when we are writing the code and we have only written a package, and we are using that constant in our code, but then sometime we might like to change it, right? So the compiler must know that there is a constant called pi, which is a deferred constant, and it has to be assigned in a package body. So that's the reason why you have a deferred constant. So if I compile this, so it's successful. So that's a correct definition of a deferred constant. Now somebody may say I might get rid of this because it's already done, right? So if I go here and if I compile this again, okay, so it's also successful. So that's also fine, right? So but then your code will not know that there is a constant called pi. Okay, so this is about deferred constants, right? Now let me tell you why there is a package body. So this brings us to a concept of functions. Now we are not going to use functions in synthesis, but we might use functions, or we will heavily use functions when it comes to testing, right? Okay, and there are special kind of functions which are called resolution functions, which are required in case you have two or more drivers for a signal, right? So in such cases you need to write functions to resolve this priority, right? So let's try to write a function. So function starts with the keyword function, and let's say max num is a function. Okay, that's the name of the function, and it receives a certain argument list, right? So let's say it receives an integer. Then the second integer it receives, for example, is b. Again, its type is an integer, right? Then return. So a function basically can return only one value, and its type has to be defined, right? So the type which is going to return is an integer, for example, integer. Now this is a function declaration. This is not a function definition. Okay, if I try to save it and compile it, it will give me an error. It will ask you where is the body of that function. So if I do compile selected, it says that the syntax error return clause. Let me see. Okay, returns. return. Okay, that's fine. Sorry. So let's see again. Okay, so let's see again. Compile it, compile selected. It gives one error. And it says function max num declared at line number 7 has no body. So what it means is that you haven't completely defined the function. So you have declared the function, but you haven't defined it. Okay, this usually happens because if you write a code, right, sequentially, then all the functions should be defined before the architecture comes in and before you use it. So basically a compiler is supposed to know what that function does, right? So in that case, like in C, you include such function declarations in the include file, right? Similarly here, you have these function declarations in a package, and the function can be defined then anywhere, right? And one good way is if there's a global function, it will be done in a package body. So let's do this again. So you have to do a declaration and then a definition, right? So I can copy that, I can paste that here, and then is. Okay, like process, function is a statement which includes all the sequential statements, right? It's like a block, right? Like a process, it's like a block, but process has a sensitivity list. So in a sensitivity list, whatever signals are there, okay, if there is an event on those signals, then the process block executes. So it's a parallel construct, okay, with a sensitivity list. While function is not a parallel construct, it doesn't have a sensitivity list, it has to be called, right? So we will see how to call a function. There are two ways of calling a function. Function can be called within the body of an architecture, and when you do that, the function is a concurrent call. But a function can also be called from within a process, right? So when it is called from a process, it becomes a sequential call. So both calls are allowed. Second, the function is basically called as a right side of assignment. Okay, so if there is an expression which evaluates to something, so that something can be a function call, right? And this is true for a signal as well as for a variable. So the function call in case of a body of an architecture would be a concurrent call which will be following the assignment statement to a signal, while in the process it will be a variable which is assigned and the right side is a function call. So that will be the sequential call to a function. So in both cases the value returned is assigned to the variable or a signal on the left hand side, right? So that's the concept of function, and function can return only one quantity and its type has to be defined, the type has to be matching, right? So now let's write the function. So we saw that declaration ends up to here which says return integer, but then if I follow it with is, then I can write the body of the function, and this starts with a begin and then it ends with the end maximum. Okay, so this would be the declaration section of a function, just like of a process, and all the rules of the declaration section of a process are also followed in declaration section of a function. That you cannot define a signal here, you can only define a variable, right? So let's do this. Okay, so it is going to the role of the function is to return here a greater integer. So let's say greater than equal to, right? So I will follow it with a sequential statement. If a is greater than equal to b, then I can say return a, else return b, and if. Okay, so that's the proper definition of a function here. So let's see if this is going to compile. So I'm going to save it. Let's say compile selected, and it's successful. That means that this is the right way to do it. So inside the package body I have a function definition, and inside the package I have the function declaration, and inside the package body I have a function definition, and all the rules of a process are applicable to a function, right? So if I want to introduce, I can introduce here a variable, right? Then that variable can be, for example, c, and that's also an integer, for example, and this is a local variable, right? Now what I can do here is, if a is greater than b, I can say c is assigned a, right? And then I can say else c is assigned b. So I'm using an intermediate variable here, right? And I'm not returning it, I'm just doing an assignment. Okay, fine. And then at the end I would have c, which contains the max of the two, and I can say return c. Okay, so this is how you do function in VHDL. Let's see if what I have done is correct. So first save it, then compile it back again. Okay, so it's successful, means that this is how I write a function, right? Okay, so I have covered that. Now, like function, there's something called procedure, right? So the way to write the procedure is procedure, and let's say max c, it is going to do the same stuff, right? And here I can say a is an integer, but then here you have to specify the mode also. So this is the input mode, so a is going to receive the input, right? Integer. Then I can say b is also a mode in, and it's an integer. This is more like an entity, a port declaration in an entity where the modes are specified. But the difference is that in an entity, that's a parallel kind of a construct, while in procedure this is a sequential construct, right? So this is how you do, same way as you do for port declaration. Similarly, you do here this. And C is going to, for example, is the out mode, and it's also going to return an integer. So it's going to return a integer, and that's the end of the story here. So procedure is declared here, but then it needs to be defined somewhere here. So to define it, let's just close this. Okay, so just 1 second. So I'm going to define it somewhere here. So here I can say procedure, so it will be the same stuff, right? So I'm going to copy the same stuff here. Control C, Control V, okay, and then is, and then there is a declaration section of a procedure, right? And this will be beginning with the begin, and then you will say and the name of the procedure, maxi. Okay, so this is how you do a procedure. Okay, now what is the difference between function and procedure? A function can return only one value, while a procedure can return as many values as it likes, provided you have provided them in the parameter list as a out, right? And then you can also do something called in out. So in out is more like passing by reference. So in C the construct is passing by reference, while here A and B are the local copies which are passed by reference, and C is also by reference. So if there is a global A and B, then local A and B is not going to do anything to that global value, right? In case of passing by value. But if you pass by reference, then you are passing pointers actually. So that concept you have to keep in mind when you do a out. So basically you can out as many parameters as you want in a procedure. But then procedure has a issue. The issue is, suppose you haven't passed anything to a procedure, but it is global, and that procedure inside this body, that value is touched. Okay, so that is called a side effect. Okay, procedures are prone to side effects. Okay, so now let's do this. Let's see if I'm recording. Okay, so let's do this. I would write the same statements if A is greater than equal to B, then C is assigned A, else C is assigned B, and then you say and maxi, and if. Okay, so this declaration, and if you were to look here, they are the same, right? Here I'm using intermediate variable C, which is local to this function, while here C is global because it's passed by reference. Okay, so I'm change the value of C. So now let's say save it and say compile selected. It's successful. That means that there is no error. So this is how you do functions and procedures, right? And let's say if I want to call them, so let's add a new file, and let's say I call this as let's say, just for namesake, okay, I call this as D flip-flop, though I'm not going to compare integers in D flip-flop, but just a construct to show you how to call a function. Okay, so I'm going to say okay, and here let's do the usual library IEEE, and then you say use IEEE dot std underscore logic underscore 1164 dot all, and then you say library. Okay, and this library is called my test. How do you know that? You know that because all the codes are going to my test here, right? So that's a my test library, and inside that library there is a package which is called circuits, and then .all. So this is how you reference a package, right? Now I am going to write an entity, and in this case entity is going to be the same as the name, which is D flip-flop, is, okay, spelling mistake, just 1 second. Okay, so here I'm writing the entity of D flip-flop, right? And here I usually like to write a port, and here D, clock, clear are in mode, and they are of type std underscore logic. And then you have Q, which is out mode, and it's again of type std underscore logic. And that's how you do the entity, and you say and D flip flop. Okay, so that's how you write an entity. Then you write an architecture, right? And I can say DFF of D flip flop is, and then it starts with a begin, and then it ends with the end, and DFF. Okay, so this is how you write an entity architecture pair. And I'm not going to write that logic here, just for my sake of testing. I am writing this D flip-flop. But let's see if it compiles. And I haven't done any syntax mistakes. So I did do a syntax mistake. So flip, so that's a misspell, flip-flop. Okay, that's fine. Now I compile this again. So that's successful. That means that the structure and the syntax is fine. Now here, let's try to make a function call. Okay, so I'm going to declare two signals, A, and it's an integer, and B is also an integer. B is also an integer. Now these constructs, okay, they have no meaning, because you know that signals have to be binary, they cannot carry integer and stuff like that, right? But just in testing, this kind of stuff may be used, but not in synthesis. So I can say A is assigned 4 and B is assigned 5, right? So I want to find out which one is greater, right? So I can call that function. I can say C is assigned, so it's like an expression, and then I can call that function. So that function is in here. Okay, it's called maxNum. Okay, maxNum, and then there is an argument list here. I can say A, is there a comma or there's a semicolon? I'm not sure of that. Let's see if it works. So let's say if this assignment works, then this works. Let's see. So let's compile this. Okay, so there are two errors. Unknown identifier C, of course. There has to be a C here. Let's do this again. Okay, so it's successful. So this is a concurrent call, because it is a concurrent statement. And the concurrent statement behaves like this, that this function will be called anytime A or B changes, right? So this will be a concurrent call. Anytime A changes or B changes or both of them change, the function would be, this expression would be evaluated. And as soon as this expression is evaluated, this value C is assigned. So the function is called based on a sensitivity list A and B, right? So this is like a parallel construct. Now if, for example, I was to surround this with a process, okay, so let's get rid of this. And if I say here, so this is not required. Okay, so I can say here a process, which is a concurrent statement, and then this process, of course, let the signal remain, signal A comma B, right, comma C. Okay, it's of type integer, right? Okay, now here I want to do a call, and this is dependent on A and B, and there is a begin, right? And then there is an end of this process, so I can say end process, right? So now here I am calling C is assigned A comma B. Okay, now this process is called, okay, this process is called whenever there is a event on A or B. Then everything inside this block, everything inside the body of a process is a sequential statement. Even the way it is done, it is like a sequential statement, right? Only simple assignments are allowed. So this would be called a sequential call. Let's see if this works. So I'm going to first save this. Then I'm going to compile, select it, and it did work. So this now inside the process, it will be called a sequential call to the function. Now a process, okay, a process would not have a sequential call, but let's say max C is called. So it is not a part of an expression as a right hand side. It is a statement in itself. That's how a procedure is called. And then you have to provide what it returns. Let's say C. Now if you do this, okay, so now what you are seeing here is this expression which is calling uh, a procedure, right? And this is a statement in itself, right? So everything looks fine here, but you see that C is not in the sensitivity list here, and C is being updated in a procedure here. So let's see, these are called side effects. So let's say compile selected. So this is an error. The error says actual signal C for class variable C is not a variable. So first thing first is that you cannot call this with a signal, and the reason is very simple. That you know when I call this process A and B, they are more or less like a variable here inside the process block, but C is not, right? So if you see here, it's not complaining about A and B, but it is complaining about C, right? So then the way to do this would be, I can say variable D is of type integer, right? And then I call this as with D. Okay, and once I'm done with this call, I can say C is assigned D. Right? So let's see if this works. Okay. Okay, it's successful. So now you can see what happens to signal A and B. Signal A and B are in the sensitivity list, but the way they are processed inside, they are like a variable, right? So in this case, when I call a procedure with A and B, there is no issue with A and B, but as soon as I put C in here, there is a issue. Now I can solve this problem by putting C back in here, and in a sensitivity list I'm going to add C here. So let's see if this is going to work. So I hope you understand what I'm trying to do here. So these things are not there in books. Of course it fails again, which says that C cannot be accommodated because C is a out variable, right? It's not an in variable, so you cannot put it in the sensitivity list here, right? So then the only option would be D, call like that, and then assign C with the value of D, whatever is returned back. So these are some finer points which you will miss when you read a book, right? So you understood how to call a procedure. This is a call which is going to be a sequential procedure call. Let's try to do this as a parallel call. So let's say Control X, and I get rid of the entire process block. Okay, let's see if I can do this. Okay, and then you will know the limitation of a process as a concurrent call. Let's see if this works, and I think it is not going to work, but depends how it treats C ABC. So if I go here, compile selected, it has an error, and the error says again the C is supposed to be a variable, right? So in this case, there is no way you can make a concurrent call because C is supposed to be a variable. It cannot be a signal. A procedure cannot create a driver. That's what it means. It can do assignment to a memory location. Assignment, it can do a location in a memory, but it cannot drive a signal. That's why C cannot be accommodated. A and B are okay because they go in as a signal, but internally they are treated as what you call variables, right? So there is no assignment to A and B, so that's why it works. While in C it has to be assigned, and a procedure cannot drive a signal. That's why C cannot be over here. So a concurrent call cannot be made to a procedure here. So you understood that there are two things. One is a procedure, other is a function. A function returns only one value. A procedure can return as many values as you define in the parameter list, right? Then a function can be called concurrently. Similarly, a procedure can be called concurrently, but then you have to be careful when you call it concurrently, right? And then they can also be called sequentially, as you do inside a process block, right? So these are the things which you have to keep in mind. Now, having said that, let's look at some more stuff, like uh, there is something called, like for example in process, okay, a process is a concurrent statement, and it has got a lot of sequential statements inside the construct, right? The body, the sequential statements are there. Is there a equivalent to a process which houses concurrent statements, right? So that will be called a block. So for example, I can say df is a block, okay, and block df, okay. Can I call something like that, and then it would have its own begin? Okay, so this is this a valid construct? Okay, this can house as many concurrent statements, not sequential statements, concurrent statements, right? And why would such a construct be used? What may happen is that I might have a block design which is designed by somebody else, but then its ports are to be mapped. So I can map those ports inside the block and then use the functionality of a block. So first of all, let's see if block is properly called here. So it is successful. It means that this is the right syntax for declaring a block. Now, next thing I can do is I can declare here. Okay, I can declare here signals. Okay, I can say D is there. So let's say D is equivalent to G, and then clock is there, which is clock in. Let's say they are named differently, and then clear is there, which is so basically here is a port actually. So the block can have a port. Okay, so I can do a port declaration here. So let's do this. Now here we have a G, which is in, and I'm doing this risk. Okay, I'm doing this live. I might not be correct, but let's try this. G is in std underscore logic, right? And clock and clear, so ck, so different names, let's say ck and cl, right? So this is your in, and then you have got o, which is your out, or capital O, which is your out, std underscore logic. Okay, so this is your port declaration for this block, and here I can say I can declare here a signal which is an intermediate signal here. So I can go here and say signal and say w is std underscore logic. Okay, now here I can say w is assigned uh, W is assigned, let's say G, when CK has an event and CK becomes 0. So as we have earlier defined, else W is assigned, okay, and we have to include clear also. CK has an event, CK becomes 0, okay, and CL equal to let's say 0. So then this regular logic works, else uh, else W when, okay, let's put the first condition as clear because it may not be synthesizable then. Okay, so let's put the first condition, which is a clear. So it will be assigned 0 when CL equal to 1 else. So basically this is asynchronous clear. Okay, else W when clock has an event and clock became 0, and in this case this, as it is in the else statement, right? So the condition for clear is checked already. Now I don't have to check this, otherwise it will not be synthesizable. Okay, else W when clock has the event and G when clock has the event and clock became 0, else W, else itself. Okay, so this is a definition of a D flip-flop. We have done this earlier also, right? It's okay. Now next is, I can say Q is assigned or O is assigned. O is assigned W. Okay, so this is how a D flip-flop was earlier designed, but this D flip-flop, assuming it came from somebody else, right? And this was its definition, right? And clearly the names don't match, right? So first of all, let's check the syntax. So let's compile selected, 3 errors. Let's see. No compile information is available. Is this that? Is the issue? Begin signal. Is there a port issue? Let's check this. Compile selected, 1 error is there. Now what's that 1 error? DF expecting block. Okay, near D, line number 24. Hang on. Near DF expecting block. Okay. So let's say it should just do a block. So then there are 3 errors. Of course, G has a formal port G, clock open, no actual association, clock clear, open, no actual association. Okay, I understood. I'll explain you what that is. Okay, so we are doing this. We have to find out the association, right? Okay, so let me just put you on pause and see what's in, what, if this works. Okay, just 1 second. Okay, so I figured this out. So it says that G has an open, no actual association with this. CK is open, CL is open, stuff like that. Okay, so let me tell you this. Okay, so this block was written by somebody else, but it was with a different port name. So this happened to be an entity which I converted into a block, right? But I don't want to write this again. So now this block is useful. So instead of entity, I'm going to copy the entire code like this and turn it into a block, right? And then I can map these ports to those ports. So you can see what is the use of this block. Okay, so I can say port map here, and here I can say G, which is of inner entity, and inner entity is mapping to D, right? And then CK is mapping to clock, and then so I don't need a semicolon. I think comma is the right thing to do, right? So this is like a value assignment, name value assignment, right, rather than a positional assignment. Then I can say CL is assigned to clear, and then I can say O is assigned to sorry about that, O is assigned to Q, and that's how the port map is done. So the one of the use of this block is I can use the code written by somebody else, and I can fragment out my body of the architecture which will house this entire entity. Only thing I'm going to do is I'm going to turn entity into a block, right? And then I'm going to do a port mapping here itself. So this allows me to use somebody else's block when the signal names don't match. So let's see if this is going to work. Okay, so it did work. So you can see one of the use of this block, right? So let's see if I can make this block useful any other way. So let's say I'm going to get rid of this and get rid of the contents of the body. Okay, let's see if I can use this guarded by a certain boolean. So let's say clock has an event, and clock became 0, right? So it is guided by this fact, and then I can say directly define here. I can declare a signal here. Signal W is a std underscore logic, right? And then I can say W is assigned, right? Okay, W is assigned D, but it is guarded by this fact. Okay, guarded by this fact. So basically D is guarded by the condition clock has event and clock becomes 0, so it is guarded by the falling edge. Okay, then I can also say W is assigned 0, the remaining condition, when clear is equal to 0, else W itself, right? So this is like a asynchronous clear. So now there are two drivers to W, but if you look at it, okay, W is guarded by this condition for assignment to D. Okay, and if this condition doesn't work, okay, still W is going to be driven by either 0 when clear is 1, sorry, else W itself. Else is going to be assigned W itself, and then I can say Q is assigned W. Okay, so this is how you can do a guarded block. Okay, so a guarding condition can be placed here, which has to result in a boolean. So let's save this and see if this works. So let's compile this. So it did work. It didn't convert. Yes. Okay, so it means that I can use blocks for two reasons. One is I can turn the entity which is written by somebody else, but it has its different ports, right? So I can do a port mapping to the higher up entity, right? So I can take the entity an architecture and convert it into a block, and then I can reuse the design. and the port mapping I can do in the declaration section of the block, right? Just soon after the port I can do the port mapping. The other use of block is I can guard the assignment using block, right? So just 1 second. Okay, so we have seen block being used at 2 places, right? So now there are few more topics which I wanted to cover in this session. One is called attributes, right? And we have seen one of the attributes, right? When we said clock, so let me just write it down here. So when we said clock has an event, right? So when we said something like that, so something like a tick followed by this event, which is a keyword, that's what we have been using in synthesis also, right? So this is an attribute, and attributes are basically properties to a signal. So let's say clock is a signal, then it has a attribute called event. So if the value of clock changes, then it will be called an event. But if the value of clock is evaluated, right, but not changed, then it is called a transaction, right? So in that case, this would be called active. So if it is a clock has a transaction, a clock is evaluated, right? So what it means is, let's say clock was something like clock is assigned A XOR B. Okay. Now A and B are the sensitivity list of a clock. So if A has an event or a B has an event, then A XOR B would be evaluated. But upon evaluation, we found out that the clock didn't change. So this will be termed as a transaction, not as an event. Okay, event would mean that the clock went through a change in the state. 0 became 1 or 1 became 0. So that will be called a event. If the clock value doesn't change, but a transaction took place, right? A or X or B was evaluated, then that would be called a transaction. That will not be called an event, right? In that case, it would be clock tick active, not event. Okay, so active is another attribute. So let's put down this predefined attributes. So let me just do that. Okay, so I'm going to talk about predefined attributes, right? And its various types. Okay, so there are 5 types. So let's see, insert error. So there are 5 types I can recall. Okay, one is called the value kind. Okay, value kind attribute. So let's make this smaller so that I have more space to write. So value kind attribute is there. Next one is called function kind attribute. Okay, next one, so this is a function kind attribute. Okay, next one is going to be called signal kind attribute. Okay, so that's a signal kind attribute. Then next one is called type kind attribute. And it's not possible to give you examples of all of them, but I would try. Type kind attribute. Then the next one is called the range kind attribute. Okay, now again there are subtypes to this. Okay, for example, value kind. So what does a value kind do? It returns a value. That's the key. Okay, so if it returns a value, then what value can it return? Okay, so it will be value type, right? It returns a type, right? Array, okay, value type. I will, for simplicity, remove this attribute. Okay, I will say value type. Okay, then again it can be array type. Not array type, sorry, value array. Value type, value array attribute, and value block. Just to be correct, let me confirm this. Value block. Just 1 second. Yes, value type, value array, value block. Okay, again the function kind attributes, basically, so value kind attribute, they return a value. Okay, so it can operate on a type, it can operate on an array, and it can operate on a block. Okay, so let's list them. Okay, because if I just keep on doing it, you might get bored. So let's look at value type here. I don't know if there will be sufficient space. Let's create some space. Okay, so let's look at value type. Okay, usually they are used on enumeration. So, and I'll just list them. Insert. Okay, so you know that whatever is the the base type, and then tick, right? So whatever is the signal, and then we say tick. In this case, it will be base type. Okay, for example, when I say color is red, blue, green, then something is of type color, so I'm not going to work with that type, right? I'm going to work with the base type, which is color. So in that case, I can say color, let's say left. Okay, so left is a attribute, right is a attribute, high and low. Okay, so for example, if I was to say insert, so I'll give you an example. Okay, and that example goes like this. I have a type declaration. I can say type color is, color is, and here I'm going to declare a type red, blue, green, yellow, orange, right? So these are colors, and this is the enumeration. This is an enumeration type which I have covered earlier, right? And then there are positional values which are associated with this. So red is 0, blue is 1, green is 2, yellow is 3, orange is 4. So the base type is still an integer. Okay, so I can say here color tick left. So I can say here, so you see it is used with the base type. It is not used with the instance of that color, instance of that type. It is used with the base type. It's a color left, so that would equate to red. Okay, and I say color right, that would equate to orange. Okay, when I say color high, that would equate to orange. And when I say color low, it will equate to red. Okay, so these are based on the position values, right? So this is an example of value type. Okay, so now let's say value array. Okay, so let's say if I have a declaration of an array, So I can do a declaration of array like this. I can say type, okay, and then I can say, or I can say subtype, or no, let's do a type only. Type, let's say my word is array, okay, and then you have to put this in the brackets, okay. Let's say 7 down to 0 of std underscore logic. Okay, so this is a type declaration. Okay, so let's see what is the attribute which I can use. Now again, it is used on the base type, not on the instance. So I can say my word length. So it will return me an integer. Okay, so it will return me an integer which will be the length of this, and that would be 8. So the output is going to be 8. So this is a value array attribute length. Okay, now there's only one of them. Now let's look at block, value block, right? So that attribute is going to return a boolean. So if I call this as structure, so that would be basically telling you that whether the architecture, so what will follow before that. So for example, in the previous example, I had written architecture df. So I can say df tick structure. So that will return me a boolean. If it is a structural style of coding of that architecture, that will give me a true, boolean true. Else it is going to give me a boolean false, right? So this is used with the architecture structure. What happened here? Okay. Similarly, I can do it behavior. So it is going to check whether the architecture style was behavior or not. So this is, and whatever, so again it's going to return me either true if it is behavior, or it's false. So if both of these return false, that means it's a data flow. So I don't need a third attribute for that. Okay, so this is a value block. So now again, so value means it is going to return a value. Value kind means it returns a value. And value type is that it is going to return a value with a associated type. Okay, which is for example the enumeration, right? Then again, array is going to operate only on arrays and it's going to return a value, for example length. And then block is going to tell me whether the block is structural or behavioral, right? For example, earlier I had a block which is called df, right? So it will tell me whether the block is structure or behavioral style. Okay, next is function kind. Okay, again these are of 3 types. So let's make it small. Okay, okay. So it can be, so what it means is that it is going to be calling a function. So whenever you do something like functional kind attributes, it means it's calling a function. Now that function can be called on a type. So this will be called function type. And we will see the examples. So this is a function type. Next one is going to be function array. Right, and the last one is function signal. So let's see one by one each one of them. Okay, let's look at function type. So basically it is going to call a function, right? So in that case it is going to be passed an argument. Okay, so I can say here let's say position. of a value. So let's say again the example here, I'm going to do a type declaration here. Insert. Okay, let's do a type declaration here. I can say type color is red, blue, green, yellow, orange, right? So this is my type declaration. Then when I say position red is going to return me 0. Position blue is going to return me 1. So basically this value I pass as an argument, and that value is going to be one of the members. Then I can say value. Okay, so what it means is I am going to pass on 0, for example. Okay, then it is going to return me red. If I pass this 3, it's going to return me yellow, right? So that's that. Okay, then I can do succeed. Sorry about this. Succeed. So I can say succeed value. So if I say succeed red is going to return me blue. Succeed green is going to return me yellow. And succeed orange will return me an error. Okay, so you have to be careful using that. Then I can also do pred, which is predecessor. So pred of blue will return me red, green will return me blue, red will return me syntax error. Okay, so that's that. So the next thing I can have here as attribute can be again, note that this function type is going to operate on color. It's not going to operate on the instance of that type. Okay, it's going to operate on color. Okay, and later I'll show you how to do it with the instance of that type. So value type here is also operating on a type. It's not operating on the instance, right? While value array is operating on an instance, right? Value block is operating on a block, right? Value function is operating on a type. Okay, it is operating a type like color, for example. You cannot say, my favorite color is type color and then say my favorite color dot pos. So then it will be confused. So it has to work with the base type here, which is color. Okay, so usually books are not clear about this. Then you can say right of value, left of value. So it returns you what is on the left, what is on the right. So this is function type. Okay, now function array is somewhere similar to this one, value type, but then it will be operating on array. So if I declare a type, okay, again it will be operating on type. So let's say if I declare a type, it will be operating on the instance, not on the type. So let's say if I declare a type, okay, and the type is going to be my word is array 7 down to 0 of std underscore logic. Okay, this one I think I have to try it out. I'm not sure, but what it means is tick left should give you range, the extreme border of the range, right? So according to me it should return you an integer. Just 1 second. Just 1 second. Array Okay, it returns a bound. Okay, which means it's a left bound or a right bound. Okay. Okay, it returns a bound of a array. So okay, it returns an integer. Okay, so if I was to say my word tick left, it's going to return me 7. If I say my word tick right, it is going to return me 0. If I say my word tick high, it is going to return me 0, and my word tick low is going to return me 7. So whatever is on the left hand side, that's low. Whatever is on the right hand side is high. Again, this works on the basic type. It doesn't work on the individual array. Okay, so that's what it is. Okay, so this is a function array. So let's put it here. Sorry about that. Okay, so that's there. Now there is a function signal, and this is an interesting one because this is the most of the time what you are using. Okay, and what these were, let's see. Okay, so here you said event. This is a functional signal kind, event. So if there was an event on a signal, then that's that. Then you say active, so it returns a boolean, right? Active. If there was a transaction on the signal, that will give you a boolean true, else false. Then it would say active event, last event. Okay, so the last event will give you a time. So remember, event is returning you a boolean, active is returning you a boolean, but last event is returning you a time lapsed on a signal when there was a last time an event on that signal. Then similarly, there is something called last active. Okay, so it is going to return a time again lapsed from the time when there was a transaction on that signal. And then there is something called last value. Last value means it is going to return you the value before the event took place on a signal. So these are called function signal attributes. Then there are signal kind attributes here. Okay, signal kind attributes are going to be only just a list. Okay, there is nothing else other than a list. Okay, so let's look at the list of this signal kind attribute. Okay, so the list goes like this. Delayed, D-E-L-A-Y, delayed. So it is going to return the signal of same kind as the original signal, which is on the left hand side, but it is going to be delayed by the specified time. So I'm not using a bracket. Bracket would mean a function call. I'm using this, and I'm using small bracket to show it is a variable. So if I say delayed 10 nanosecond, so whatever is the signal, whatever is the type of the signal, so for example, it was std underscore logic, then the result of this would be also std underscore logic, but it will be, the signal would be delayed by the specified time. So I can say clock tick delayed 10 nanosecond. So what it means is that whatever the clock is running, generate the same type signal, okay, which may be std logic or bit, right, but then delay it by 10 nanosecond. So that's what it means. So that is delayed. So it returns the signal of same kind. So then the next thing is quiet, and then it is going to return you a boolean. So it's going to say whether the signal was quiet for a specified time. So if I say clock quiet and then 10 nanosecond, so it's going to go back for 10 nanosecond, and see if the clock was silent for that 10 nanosecond. There was no event on it. If there was no event on it, right, then it's going to come up with a boolean true. If there was an event in that 10 nanosecond, then it will come with false. Okay, so that has been quiet. Okay, now with the quiet, it is not just the event, it's the transaction also. So the signal clock, for example, if it had a transaction also, then also it will be covered by quiet signals as well as events as well as transactions. But if we were to specifically look at events, then there is another attribute. Okay, that attribute would be called stable. So there is a very small difference you should know between these two. Okay, the small difference is quiet takes account of both events and transactions, while stable take account of only events. Then there is a tick transaction event transaction attribute. Okay, so what this transaction attribute is, it's going to return you a bit. Okay, and that bit is going to toggle whenever there is a transaction on that signal. So for example, clock is equal to A XOR B. So whenever A XOR B is evaluated, that expression is evaluated, then the transaction will return you a toggling of a bit. Okay, whenever the transaction takes place, there will be a toggling of this bit. So that's signal kind attributes. Then type kind attributes, right? Now up till now we have been talking the base type. Now let's say I declare a type here. Okay, and let's say the type is color. So I can say type, sorry about this. Okay, I can say type color is then I can say red, blue, green, yellow. Okay, so let's do this here. And mind, all the attributes work on signals only, not on variables, so you have to be careful not to mix it with variables. Okay, so let's say this is my type declaration, and then I go ahead and take an instance of that. So let's insert another text. I can say my color is of type color, correct? And this has to be a signal, so I can say signal my color is of type color, right? And then I can do the assignment. Okay, I can say my color equal to red. Okay, so in this case what I can do is I can get hold of the base of my color, and that is done by this attribute. So if I go here, so there is only one attribute here available, which is to get the base of that type. So this would be called base. Okay, so I can write here my color tick base. Okay, so what this will return is color. So what is the base of my color? The type color. So the color, let me see if I'm recording or talking to myself. Okay, so the color is going to be returned by my color tick base, and then I can apply any attribute now. It can be a value kind, it can be a function kind, right? So I can apply any attribute. So for example, I can say left. So in this case, let the my color value be red or blue or green, but as soon as I say my color tick base, it's went to color type, and then when I say left, it will return you red. If I say right, it will return you yellow. So base is used for getting to the base type of that instance. Okay, so that any value kind or function kind attribute can be applied on it, right? So that's that. Now another thing is when we run loops, right? So when do you say, when you run a for loop, for example, so I'm going to write you an example of a for loop here, which is going to work on an array, for example. So usually how do you do that? You say for I in range, for I in range, okay, and then you say 0 to let's say n minus 1 loop, okay, and then you say end loop. Okay, so in this case I is basically the indexer, which is going to index through the array, right? You can say let the array be A, then you can say AI, right? I think it became capital. Okay, you can say AI, right? So that's how you are going to index, right? Now if I do not know what is the range, so I can say A and tick range loop. So now this works. It returns me the lower bound as well as the upper bound. Now I don't have to worry about whether it is going to be 2, 0 to 7, or it's going to be 7 to 0. Okay. Now here you have to be careful that you can say range. So if it is 2, you are supposed to use range. But if it is down to, then you are supposed to use range, reverse range, right? So then you can say reverse range underscore range. Okay, so these are the two attributes under range kind attributes. So if you look at this chart, right, this chart basically gives you all the attributes possible in VHDL, and you will see that in the synthesis we are hardly using one, which is event, while in verification or assertion based testing I can use any stuff, right? I can check on the signal using the function signal kind, right? I can check on the signal. I can also check on using signal kind attribute. I can check on a signal and generate something which is, checking the last value, or checking whether it is stable or quiet, or whether generating something which is delayed by something, some amount, right? So this kind of things are used mainly not in synthesis, but they may be used in testing or verification, right? So that's why I covered these attributes. Now showing the example of all of them is very difficult because it's very time consuming, but I have tried to show you some of them, their examples, right? And where is the practical use of it? Mostly in assertion based testing, mostly in verification, and sometime in testing which may be hardware related. For example, I might have to skew the clock by a certain amount and then apply to a circuit. Okay, I might use something like this, and practically what will happen in a FPGA, it will put in buffers to generate that kind of time delay, right? So when you do timing synthesis, you might be running into something like delayed, but these are the attributes here which are available in VHDL. So I have taken your 1 hour, so I am going to stop here. Thanks a lot. Thank you very much.